Hey guys, it's time for week four's lesson review. There aren't as many practice problems this time, but I will post a link to our previous video on the same topic, which was from not long ago. So, we're approaching one of my favorite things. You know how much I love trigonometry. I love trig. Sorry guys, I'm enjoying this. Now, you do remember I will be posting links to those videos with the songs or reposting them again. Remember the person who sang the Sokotoa song out loud actually got his problems right? So make sure you listen to them. Sometimes they're a little annoying. I understand that. But those songs that we have for these topics are actually quite helpful when it comes to remembering how to solve them. All right, so let's go ahead and get started. Okay, so normally we would go left to right and up, down, but we're going to start over here on the right-hand side today because it already here talks about our trigonometric ratios, and those are our SOHCAHTOAs. So remember, the trigonometric ratios are based on which angle is currently the one you're focusing on. So remember one thing I told you in the last video, which was the corrections for the week 3 problems, and something I want you to always do, is always when you see a right triangle, first thing you do, label your hypotenuse. Find your right angle, go across, label the hypotenuse every time. It will help you. The other thing I want you to do is if you are given an unknown angle and some sides, or unknown sides and angles, figure out which angle they are talking to you about and highlight it or trace it. So notice here we have sine of x. Angle x is right here. So we're going to go ahead and fill in this spot with some color. Now, when you do that, the two sides you will always highlight are your hypotenuse and adjacent sides. It is not a standard that, like with A, B, and C, where it doesn't matter if A is one and B is the other, or B is one and A is the other. In trigonometry, it matters which side is which. The side that's always the same is the hypotenuse. That's the longest side. It is across from the 90-degree angle. And now we are not labeling this triangle any longer with A, B, and C because we were not given two sides and asked to find the third. If you are given two sides and asked to find an angle, trig. A side and an angle and asked to find a side, trig. That is the options you're going to be doing. Okay, and if you are doing a trigonometry problem, you will be labeling your sides A, O, and H instead of A, B, and C. All right, please do not forget that. That's where most of us had troubles when we did this the first time and the second time. So we have our sine, which is opposite over hypotenuse, or SO for our mnemonic, which is SOHCAHTOA. Remember, I prefer to write so like this, S and then O, H, so that it is sine equals opposite over hypotenuse. And what that means is you take your opposite side and put it over the hypotenuse. Cosine is the second one, and goes with the acronym CA, C-A-H. It is adjacent over hypotenuse. And then we have tangent, which is our TOA. Tangent is equal to opposite side over the adjacent side. So these are ratios, okay? Something equals the relationship between one side to another. Sine is equal to the relationship of the opposite to the hypotenuse, okay? Cosine is regarding the relationship between the adjacent and the hypotenuse, adjacent to hypotenuse. And tangent is the ratio of opposite to adjacent. We need to make sure we pay attention to that. So what you can do is find the angle that you're looking at, label all sides, and then regard it with whatever, fill in the formulas with the information that you have been given. All right, so let's look at the example that they pulled from the internet for you. And it has a triangle XYW with side lengths A and B, and one leg is 5. They gave us angle Y is 65 degrees, and they want us to find A and B. So this is what we would do if we're missing a side, okay? So let's focus on A first. All right, so let's first look at the information we've been given. First thing we have is angle Y, which is 65 degrees. So we are going to highlight that angle. That is our angle. The next thing we are going to do, which we should do first in every triangle, is label the hypotenuse. I know this is the hypotenuse because it is opposite the 90-degree angle. So remember, if I said whenever you highlight the angle, you will highlight two sides, adjacent and hypotenuse, A and H. So that means the side label 5, XY, that is our adjacent side. And our opposite side, which is the one across from the indicated angle, is going to be side A, and that's going to be opposite. So let's do some labeling, make a list of our information that we have. All right, so we know that angle Y is 65 degrees. We know that our opposite side is labeled A in the picture. Our adjacent side is 5, and our hypotenuse is B. So I don't really like that they used B there with the hypotenuse because we never use B as the hypotenuse. But that's what they gave us, so that's what we're going to work with right now. So I apologize for the confusion there. If it makes you more comfortable, cross out that B and just label it H, okay? So let's go ahead and find A. So A is the opposite. We have opposite information, and we have adjacent information. So in relationship to angle A, we have opposite and adjacent. So if we look over on the right-hand side for our trigonometric ratios, we have to ask ourselves which ratio uses the opposite side and the adjacent side, okay? And in that case, that's tangent. So what we're going to do is we're going to put tangent of 65 degrees is equal to our unknown opposite side over, and I'm actually going to label it O. I don't want to label it A. That makes me mad. O, okay? O over our adjacent side, which is 5. All right? That is an O, not a 0. Okay? And then we have tangent of 65. Tangent of any number is just another number. So what we're going to do is treat it like a number. So we have a number is equal to an unknown value divided by 5. We need to use our inverse operations to get the 5 out from the denominator. And so we're going to multiply both sides by 5. And so we end up with 5 times the tangent of 65 degrees is equal to the opposite side length. So we're going to have to run this through the calculator because, again, to be perfectly honest, I don't know the tangent of 65 degrees off the top of my head. All right, so for now, again, I'm using the TI emulator, which is on my computer. If you do not have access to the TI emulator, please use the calculator on your cell phone or the one on the computer itself, or you can use an online one, okay? I will, at the end of the video, give you the easiest option that I can find for our current situation, all right? So all we're going to do if we're using the emulator or any other graphing calculator is literally type what we saw, 5 tangent, and we're going to have to go to our trig button, tangent of 65. And that's all there is to it. And we get 10.7225. Okay, and that's equal to our opposite side. We're going to go ahead and just round it to the nearest hundredth. So A is 10.72 because this 2 right here is less than 5, so we round down. Now let's go ahead and find out what the hypotenuse is. So again, we are given the hypotenuse and adjacent. So we have an adjacent side, we have an hypotenuse given information about, or that we're trying to find information about, and we have an angle. So we have adjacent and hypotenuse, so we are going to do cosine, that's the C. So we have CAH. All right, so cosine of the angle we're given is equal to the adjacent side, which is 5, over the hypotenuse, which is now, there is a shortcut on this one. I'm going to go ahead and write it out, and then I'm going to switch over and show you why it works. So whenever we have a variable in the denominator, there's a couple of steps we could do to take it out. The fastest is to just switch it with the other side of the equal sign. So we have b equals the cosine of 65. All right, so b is equal to 5 over the cosine of 65. So why can I do that? So let's take a little bit of a brief tangent and just do this with any fraction whatsoever. So let's say that 5 was equal to 10 divided by x. That's a pretty simple equation, and it will work just as well to demonstrate the situation. So that's our first equation. 5 equals 10 over x. So again, what we would do normally is multiply both sides by the denominator, and now we would have 5x equals 10. Well, to get x by itself, then our next step would be to divide both sides by 5. And so then 5 divided by 5 is 1. We get x. And then 10 divided by 5. I'm going to leave it as 10 over 5, even though that does equal 2. But it's just to demonstrate the principle. So if our original equation was 5 equals 10 over x, and our final equation is x equals 10 over 5, we can see that x and 5 have just switched places. So that's why that works. So what on earth do we do with that information? Well, we're going to put it in our calculator, and we can put it as 5 divided by the cosine of 65 and hit enter. And we get 11.831. All right, so we get that b is approximately 11.831, which was our hypotenuse, and our adjacent side is still 5, and our opposite side, which was labeled A, is 10.72. So I'm going to give you some brief assistance on the practice problems. Practice problem number 1 says Suzanne and Mindy were solving problem below involving trigonometric ratios for their homework. Which of the following would help the girls find the value of y? So let's look at y. Now, they gave us an angle in this problem. And in this answer choices, all the angles are 61 degrees. So let's go ahead and focus on the 61-degree angle. Okay? So first thing we should do is find our hypotenuse, and that's going to be side x, which means y is our adjacent side, and 13 is our opposite side. So we need to see which two pieces of information in relation to the 61-degree angle and y do we have. We have 13. X and z are unknown, so I wouldn't recommend using them. So go ahead and take a look at what we have. We have opposite and adjacent. Which angle ratio uses those two? And then how would you set it up? All right, and number 2 wants you to find the side length, the length of AT. If we look across on our triangle, AT is our hypotenuse. So that is one thing we want to do. The angle given to us is the 66-degree angle. So if AT is our hypotenuse, what is AR? Ask yourself that question, and it'll help you set it up and figure it out. One hint I will give you on this one is anytime you're solving for the denominator, which is the hypotenuse in this case, hypotenuse in our standard trig is always the denominator. In standard trigonometry, if you are solving for the hypotenuse, you will have a fraction. So that eliminates a couple of your answers. Think about it. All right, and the last one I'm going to set up is number 3. On the map below, Main Street, 10th Street, and Highway 1 intersect to form a right angle, which is right here. The distance between 10th Street and Main Highway Main Street along Highway 1 from 10th Street to Main Street along Highway 1. So from 10th Street to Main Street along Highway 1 is 5.6 miles. Which measure is closest to the main street, X, from High Street to 10th Street? Okay. Sorry, Highway 1, not High Street. Highway 1 to 10th Street. So we have our angle, 40 degrees here. We need to label our hypotenuse. And we know that's our hypotenuse because it's opposite the right angle. Highway 1 is which side of the triangle? Which side of the triangle? All right, so now we're going to talk about inverse trig. So it's still important to remember our SOHCAHTOA. Okay, so SOHCAHTOA. All right. And so therefore, we need to make sure we know which angle we're curious about and then what information we have. Okay, so if you click on the link that goes with this Eiffel Tower picture, it says a tiny but horrible alien is standing at the top of the Eiffel Tower, which is 324 meters tall, and threatening to destroy the city of Paris. A man in black agent is standing at ground level 54 meters across from the Eiffel Tower, across Eiffel Square, aiming his laser gun at the alien. At what angle should the agent shoot his laser gun? So let's go ahead and fill in that 54 meters because our picture doesn't have it. All right, so I also plugged in the meters because that was bothering me. So we have this angle here is the angle where our man in black agent is hanging out. This is our dude. He's hanging out across Eiffel Square. And he wants to kill the alien who's up here. And so we are going to figure out what theta is. That little circle with a line through it is theta. So what is the measure of theta? Well, how do we find that out? Well, when we're missing a side, we use regular trigonometry. If we're missing an angle, we use inverse trigonometry. Yay, trig! When we teach you how to do one thing, we always teach you how to go back and undo it. It's the first time I'm doing it in the same day. All right, so we have this angle here, angle theta. The line of sight is the hypotenuse, which means the ground is the adjacent side. And so the Eiffel Tower is the opposite side of our triangle. So let's go ahead and fill in the information that we know. We know the adjacent is 54 meters, and the opposite is 324 meters. So we have the adjacent side and the opposite side. Again, which trig ratio does that mean? It means tangent. So we are going to have a problem set up as the tangent of angle theta is equal to the opposite side, which is 324 meters, over the adjacent side, which is 54 meters. But now we need to solve for that unknown number. Theta is unknown here. So what I'm going to do is I'm going to switch over to another screen so that we can work this out. All right, so we have tangent of theta equals 324 over 54, and we need to solve for theta. Now, if we know our shortcuts, we know that theta will be equal to the inverse tangent of the same ratio, 324 over 54, okay? But how do we get from here to here? Now, if you know the shortcut, you know your patterns, you can skip straight to this step. That is acceptable. But there is actually a step-by-step way to get there. All right, so the way we do that is theta is it needs to be by himself. He needs to be quarantined. He's very sick. Okay? So we need to undo the tangent. Undo the tangent. Now, how do we undo things? Tangent is an operation in this case. When we undo operations, we do the inverse operation. So the way this is going to end up looking is tangent inverse of tangent theta equals 30 tangent inverse of the ratio. So we're going to do this to both sides. I'm going to write the ratio in purple again. So much for my color consistency, guys. Okay. Inverse tangent and regular tangent. The inverse tangent of the tangent is just the angle. So we're left with theta equals the inverse tangent of the ratio 324 over 54. And then we're just going to run that through our calculators. So where are our inverse trig functions? Well, they're right here with our regular trig functions. So we'll take tangent inverse, and we will put 324 divided by 54. Make sure, let's go ahead and check that real quick, that your calculator is set to degrees, not radians. So mine is set to degrees, we're good to go. So now I'm going to hit enter. And that gives me 80.537. It wanted me to round to 2 decimal places. All right, and since the 7 is higher than 5, we're going to round the 3 up. So theta is approximately equal to 80.54. All right, not quite straight up, but getting pretty close. Okay, so what we're going to do is we are going to go ahead and set up practice problem number 1, and it wants us to focus on angle D. So angle D is right here. I'm going to go ahead and label this side. We can even shade it all in. I like to highlight it all the way in, but the highlighter on this app doesn't work unless you're highlighting text. So that's my angle. I need to label my hypotenuse, and then the other side that's shaded is adjacent. And so the last remaining side, the side that is not labeled, is opposite. So we have an angle, a measure of angle D is unknown. We have the adjacent side is unknown. But we also have the opposite side, which is 5, and the hypotenuse, which is 13. If we remember our SOHCAHTOA, which ratio uses opposite and hypotenuse? Set it up that way. Okay, so notice how number 2, it's asking us to find angle F. It is the same picture. So your numbers are the same. I'm going to go ahead and highlight the angle for you. Remember, let's label our hypotenuse. And where 5 was the opposite last time, now it's the adjacent. So go ahead and make your list. We have our measure of angle. F is what we're looking for. The opposite side, we don't know. We don't actually care. We could figure it out if we really wanted to by using Pythagorean theorem, but who cares right now? Adjacent is 5, and hypotenuse is 13. So that's what I'm going to set up for you. Make sure you label your triangles and highlight your angles every time. It'll make it easier. All right, so there's 2 things I want to show you about calculators. If you are using any standard Windows calculator, or pretty much even the one on your phone, the one on your phone, usually you just have to turn it to the side to get your additional functions. For the one on your computer, the standard one, you're going to go ahead and hit the menu bar, and I would use the scientific calculator. And see how here it has the trig functions? We have sine, cosine, tangent, and then you hit second, and it gives us sine to the -1, cosine -1, tangent -1. And those are going to be our trig functions on a standard calculator. If you do not have access to the standard calculator either on your computer or on your phone, or you're just struggling with them, go to desmos.com. You can see it spelled right here, DESMOS. There's usually links to Desmos right here on the Google document that we give you. And the one you're going to want to use for trig for the most part is your scientific calculator again. Okay, because you want to be able to use sine, cosine, tangent, and here's our inverse. If we hit function here on Desmos, it'll give us sine, cosine, tangent, and inverse sine, inverse cosine, and inverse tangent. If you are struggling with any of these problems and you can't get access to me as quickly as you'd like, let's say it's 2 in the morning, because I've seen some of you turning in your homework at 2 in the morning, you can always go to wolframalpha.com. And one thing I do like about Wolfram Alpha is it generally has a place where you can Google. So let's say cosine of 45 degrees. Just type it in there. It'll take a moment. Assuming ratios, 1 over square root of 2. Don't ever leave that radical in the denominator, but we'll figure it out later, okay? All right, so we're going to wrap it up here. Make sure that you work through the problems. If you're not sure about your answers, just check compared to how I've got them set up, and you can send me an email at any time. Have a great day, guys.